must go for large air gap. So air gap plays an important role in designing of your induction motor. Now, design of squirrel cage rotor. As you all know, there are two types of rotor: squirrel cage type of rotor and slip ring type of rotor. So the design of squirrel cage motor includes your design of rotor slots, after that design of rotor bars and slots. As you all know that rotor bars are placed in the slots, so in that rotor bar current you have to calculate rotor bar current first. After that you have to calculate area of rotor bars. After that, shape of rotor slots. As we have studied the shape of stator slots, there are two types of stator slot, which is open type and semi enclosed type. Here some different type of shapes are used. After that, fourth one is rotor slot insulation. Next, design of end rings. End ring, so in design of end ring, you have to first calculate the end ring current. After that, second one is nothing but your area of end ring. The first one is design of rotor slots. Now this is the practical rotor having some slots. This is the first step in designing of rotor, and previously we have discussed some rules to design or to calculate stator and rotor slots. That is most important for selecting the rotor slots. And if there is a fault in selection of stator and rotor slots, your motor may behave abnormally. What is the abnormalities you have observed? That is refusal to start, which is we are calling it as a cogging, or it may rotate at some sub-synchronous speed, which is called as cogging. So if you select, or if there is a fault in selection of stator and rotor slots, you will observe the phenomenon of cogging as well as crawling. Normally these effects are produced by harmonic fields, which are created due to windings, slotting, saturation, air gap, irregularities. Now, harmonic field has more number of poles like NP. Now, if you select uh, more number of poles, suppose number of poles equal to 4. Here one example is given. Suppose you are having number of poles equal to 4 and the third harmonic. If your motor is having third harmonic present over there, then your number of poles will increase virtually. So total number of poles will become 12 here. Now what will happen if you increase the number of poles? If you increase the number of poles, your speed will decrease. Now this is the impact of your harmonics. Harmonics will increase the number of poles here, and if your number of poles are increased, your synchronous speed will decrease, and this decrease in synchronous speed or subsynchronous speed is nothing but your crawling phenomena. So this is the impact of harmonics. Now this is the waveform for harmonics. Now suppose this is your fundamental frequency. This red color frequency is your fundamental frequency. After that, this blue color is nothing but your third harmonic. After that, this green color is your second harmonic, and this black color black color line or black color waveform is your second harmonic, green color is your third harmonic, and this blue color is nothing but your fourth harmonic. So this is the impact of harmonics on your on the performance of your induction motor. Now second one, design of rotor bars and slots. Now here this is a practical squirrel cage rotor. So as you can see here, these are some rotor copper bars which are skewed at some angle. As you can see, they are not parallel to the stator shaft. So here they are skewed at some angle, and this is nothing but your end rings. They are shorted at the end rings. Now here, design of rotor bars and slot. Now how to design the rotor bars? But before designing of rotor bars, you must know the rotor bar current. So you have to calculate rotor bar current first. Now how to calculate rotor bar